Hello friends, in this video lecture we will see first come first serve scheduling algorithm with example. What is first come first serve scheduling algorithm? In this first come first serve scheduling algorithm, the process that requests CPU first is allocated first. Means the process which come first will get the CPU first. So that is the idea of first come first serve scheduling algorithm. This first come first serve scheduling algorithm is managed by FIFO queue, that is first in first out. It is non-preemptive type of scheduling algorithm, which means running process will not be preempted if there are number of processes in the ready queue, and CPU will be assigned to the next process after execution of the running process. Means after successful execution of the running process, CPU will be released and will be given to the next process, or CPU switches from running state to the waiting state as result of IO interrupt. That is non-preemptive scheduling algorithm. Here are some merits of first come first serve scheduling algorithm. First is its code is simple to write and understand. This algorithm is easy to understand and easy to implement. It doesn't have starvation if the initial jobs have smallest CPU burst time. Some demerits are there. In this algorithm, average waiting time is long and it may cause starvation if initial jobs have longest CPU burst time. Let's take problem based on first come first serve scheduling algorithm. Consider the following set of processes with given arrival time and CPU burst time. Compute average turnaround time and average waiting time under first come first serve scheduling algorithm. Here, what is turnaround time? Turnaround time is basically completion time minus arrival time, and waiting time is turnaround time minus burst time. Here, arrival time and burst time are given in the problem. We have to compute completion time to get the turnaround time. Here, sketch the NAT chart first. As per NAT chart, at 0, which process will be executed? P0 will be executed as it come first. For how much time? CPU burst time for P0 is 4. Means till 4. After P0, next process is P1, which arrive at 1. P1 has CPU burst time 3. P1 will hold CPU for 3 units, that is 4 plus 3, 7. After P1, there is next process P2. The burst time for P2 is 7. P2 will hold CPU for 7, means this 7 plus 7 is 14. The next process is P3 in the queue. P3 will hold CPU for 5, means total time is 19. You can cross check the time on the NAT chart with the total burst time, that is 4 plus 3 plus 7 plus 5, that is 19, and here we have 19 on the NAT chart. We have to compute completion time for each process. Process P0 completes at 4, process P1 completes at 7, process P2 completes at 14, process P3 completes at 19. So what is turnaround time? It is completion time minus arrival time. For P0, completion time is 4 and arrival time is 0. Then its turnaround time is 4. For P1, 7 minus 1, that is 6. For P2, 14 minus 2, that is 12. And for P3, 19 minus 3, that is 16. What is total here? Total turnaround time is 4 plus 6 plus 12 plus 16, that is 38. So average turnaround time is 38 divided by number of processes, that is 4, is 9.5. Now compute waiting time, which equals to turnaround time minus burst time. We have already calculated turnaround time and burst time is given here. Turnaround time for process P0 is 4 and the burst time is 4. 4 minus 4, that is 0. For P1 it is 6 minus 3, that is 3. For P2 12 minus 7, that is 5. And for P3 it is 16 minus 5, that is 11. So total is 0 plus 3 plus 5 plus 11, that is 19. So average waiting time is 19 divided by number of processes, that is 4, equals to 4.75. Hope you like this problem based on first come first serve scheduling algorithm. Thank you for watching. Have a nice day.